Hello, this is Don with MecSoft Support. Today we're going to be looking at Rhino3DPRINT 2017. And in this video we're going to be doing Quick Start Guide number 3 in a series. And for this video we're going to be creating a cavity block from an STL file. First, let's review the steps we'll be taking to complete this guide. We'll launch Rhino3DPRINT and open the STL file. Then we'll diagnose the mesh for possible problem. We'll use Stitch and Close to combine and fix the mesh. Then we'll use Reduce to simplify the mesh. Then we'll create a box for the cavity block. Finally, we'll subtract the mesh from the box to create the cavity. Okay, after you install Rhino3DPRINT, you'll find a Rhino3DPRINT menu item on the main menu. If you drop that down, the first thing I want to talk about is the Welcome option. Select that and the Welcome dialog will display. And what this gives you is links to resources about the product. Now, if you're not comfortable with working with videos to work with tutorials from a video, you can get this same Quick Start Guide in a PDF document just by selecting that option. And it'll display the PDF document for you and you can work from there. Okay, let's close that. Also, from the Rhino3DPRINT main menu, you have the browser option. Now, the browser displays on the left side by default and contains all of the menu items you need and commands to work with meshes within Rhino3DPRINT. Now, the dialog is divided into two sections. The upper section, you have a ribbon bar where you have various commands that are grouped under the Create tab, the Model tab, the Inspect and Modify tab, a Repair tab, and a 3D Print tab. Under that, you have the data tree, where all of the objects you create are listed here. Then we have a browser toolbar below that, and then also an information window. Now, this information window will duplicate for the command dialog when you select a command. So let's get started and open the file. From the Rhino3DPRINT install path Quick Start folder, select the part carmodel.stl. And if you can't find this part, just change your part selection to STL files and it'll isolate it for you. Open that part. For the STL input options dialog in Rhino, we'll check the box for weld angle and have that set to 22.5 degrees. And check the box for split disjointed meshes and set the units to inches and pick OK. Let's take a look at what we got. We have a part here that's a model of a car. And if you see over here in the browser, you'll see that we have 313 mesh objects over 130,000 facet triangles. Now, the first thing we want to do with any part that you import or create from a point cloud or any imported files, you want to do some diagnostics to see what you have to work with. So, from the Repair tab, let's pick the Diagnose icon. We'll select the meshes, right-click, and pick the Run Checks button. You'll see that we have over 26,000 open edges. These need to be fixed before you can 3D print any part. It's got to be a closed volume. So we can fix those pretty easily. What we're going to do is let's turn off the meshes and shade the part so we can see this a little bit better. Now, what we have here is we have a car model and it's an open shell with over 300 mesh objects. We're going to use a command called Stitch and Close in Rhino3DPRINT. What that's going to do is it's going to stitch all the meshes together. All of the open edges are going to be sealed, and it's also going to close the mesh, so this bottom will also be closed so that we have a closed volume. Let's pick the Stitch and Close icon, select all the meshes, right click. Now, depending on the size of your model, this could take anywhere from a few seconds to a minute. Okay, now we have one mesh in the data tree with 170,000 facet triangles. So here we go. We also can see that the mesh is closed, and let's just do another diagnostic just to make sure. Select the mesh, right click, and run your checks. 0 open edges, that's what we want. Now another command that I want to show you in Rhino3DPRINT is the ability to simplify your meshes by reducing the triangle count. Now, it's not necessarily reducing the accuracy of your model per se, but it's just reducing the total number of facet triangles. Now we can see that we have 176,000 triangles. Let's select from the Inspect and Modify tab. Let's pick the Reduce option, select the mesh, right click, and we'll set the slider to reduce by 25% and pick the Reduce button. So now we see that we have one mesh and 130,000 triangles. So that makes it just a little bit easier to work with when you go to 3D print your part. Turn the mesh wires back on if you want to see the meshes. Okay, now what we're going to do is we're going to create a cavity block. So we want to create a box, and then we'll subtract the car from the box to create the cavity. Let's go to a 4 viewport layout. Now from the Create tab, let's pick the box command, and over here on the right side view we're going to zoom out a little bit and make sure that your object snaps are turned off down here in Rhino, and we'll pick a point on the center of the car above it, right on the center line, and then we'll pick another point on the lower right side, completely enclosing half of the car. Now we're going to drag the length of the box from the front view to make sure the entire car is enclosed. Okay, let's activate the perspective view. We see that we have another mesh added to the data tree. That's our box we just created, and then our car. Let's go ahead and subtract the car from the box to create our cavity. From the Model tab, we'll pick Subtract, select the box, right click, and then select the car and right click. Now we have a nice cavity block with our car subtracted, ready to go ahead and do some more mold design, or if you want to go ahead and 3D print this cavity the way it looks like this, you can go ahead and do that. Well, this is it for this tutorial. You can visit us on the web at www.mecsoft.com for more tutorials and more information about the product. Thank you.